So the last thing I want to do here is kind of a preview for what we'll see in Chapter 5, because really talking about this stuff in the context of discrete functions doesn't quite work in the same way. It's not quite as interesting, it's not quite as in-depth as what we'll see in Chapter 5, but it is still important to mention here because we do talk about binomial CDF and binomial PDF, so we should have some idea of what those letters actually mean. Or what they're talking about are things called distribution functions, where a distribution function essentially is just some function, some equation that is designed to be able to tell you something about probabilities associated to random variables. And there's a great deal of depth to this stuff that you can get into in courses on probability theory. You can spend a long time working with, but we're not going to see most of that here. The main things we're going to see are things called PDFs and CDFs, where PDFs are probability density functions. Sometimes you call those just probability distribution functions or point density functions. There are a bunch of different words for very similar things, where essentially what a PDF does is it says, give me some information about a specific value in the distribution, and I'll tell you something about what the probability associated to that specific value is. So PDFs are specifically for finding probabilities of well-known variables at specific values. Meanwhile, CDFs, those are cumulative density or cumulative distribution functions, again, depending on context, what we're looking for and what we have. But what these do is they take accumulations. Generally, they take accumulations up to a point. So CDFs are for accumulating. They're for saying, okay, I want to know how much probability everything up to this point has, or sometimes everything beyond, or even occasionally everything between 2 points. And I'll say that for people who have some calculus, we're going to see more of this in Chapter 5, but essentially what's going on here with these PDFs and CDFs is a lot of work with integration, a lot of work with finding areas underneath our curves, underneath the curves of our distribution functions to find our probabilities. However, those are not simple integrals, for those of you who know calculus. In order to actually do this stuff, it takes a lot of work, a lot more than what you'd see in even your first few semesters. In fact, I'd say that if you can do everything you see in this class without a calculator or a table or some form of computation software, I have no idea what you're doing here, because you're better at probability theory than I am. But don't worry too much about those details, and don't worry if you don't have any calculus in your background, because this all seems strange and weird and well outside of what we need, because, well, it is strange and weird and a bit beyond where we're going to get. Mainly, though, just understand that when we're looking at these distribution functions, think PDFs are for points and CDFs are for accumulations, and we're going to be seeing a lot more of this when we get into Chapter 5, talking about the normal distribution. But those are concerns for people after Exam 2. For now, let's focus on this stuff. Good luck preparing. Hopefully you all do well, and I'll see you next week.